So class, now let us learn about the continuity of a function. And for example, here on the screen you have a function f of x equal to the modulus of x minus 5, and you have to check the continuity of the function at x equal to 5. So continuity means, in simple words, the continuity of the graph, whether the graph of the function has any gap at x equal to 5, where x equal to 5 is a number on the x-axis, and our aim now is to check the continuity of the function at x equal to 5. And now the function f of x equal to the modulus of x minus 5 can be written as f of x equal to x minus 5 whenever x is greater than or equal to 5, and f of x equal to 5 minus x whenever x is less than 5. Now, for example, f of minus 3. So since minus 3 is less than 5, we use formula number 2, and you will get 8. F of 3, so 3 is still less than 5, so we use formula number 2. And f of 6, since 6 is greater than 5, so we use formula number 1. But on the right hand side, if you observe, all the values are positive, showing that the graph is always above the x-axis. And this is very important to note down with. So you can see on the screen that the graph is always above the x-axis, because the value of the function at any real number which is along the x-axis, it is always positive. So the graph is above the x-axis. So since our aim is to find out the continuity of the function at x equal to 5, now let us take these 3 examples. In the first example, you have the number 5 in the middle, and what will you do to find out that number which is just before 5, or that number which is just after 5? But you know the length of the gap from 5 to that number on the left, or the length of the gap from 5 to that number on the right. So to get that number on the left or on the right of 5, if we know the length of the gap, we simply subtract the length of the gap from 5, or simply add the length of the gap from 5. So you will get the number 4 and the number 6. They are just before 5 and just after 5. Now the second example is the same thing, except the numbers on the left and on the right, they are far apart. But the third example is a very important one, because x is a number which is very, very close to 5, and that length is h. It is a very, very, very small gap, but I have shown here in a very expanded image. So, but actually they are very, very close. X and 5, they are very close. But you know here the length of the gap is h. So that number x, which is just before 5, can be written as 5 minus h, and that number x, which is just after 5, can be written as 5 plus h. Simple. Now in notation, we know that if x is very, very close to 5, then in both cases h should also be a very, very small number, and that small number is 0. So in notation we write like this: as x approaches 5 from the left with a minus sign on the top right of 5 to show that x approaches from the left. So h should also approach a very small number, that is 0. The same thing to the second notation. So first, we find out the value of the function at 5. So f of 5 is equal to 0. Now the left-hand limit, LHL, is written as limit f of x as x approaches 5 from the left. So here, f of x, we understand it should be 5 minus x because x is approaching from the left. X is less than 5. So 5 minus x. Now when you replace x by 5 minus h, because x is on the left of 5, so 5 minus h, so h should be approaching 0. So there's a change in the variables here. You should note that down, you should not forget, and you'll be getting after that limit h as h approaches 0. So h is a very small number, becoming very, very small, so that should be 0. It cannot be negative because h is a length of the gap, so it is at most 0. The same, it happens to the right hand limit, and I hope you will try to understand on your own. So when all the three, they are equal, that means the function is continuous at x equal to 5. So when the left hand limit equal to the right hand limit equal to f of 5, then we say that the function is continuous. So in the same way, you can find out the continuity of the same function at x equal to 4 or x equal to 3 or x equal to 0 or x equal to minus 1 or minus 2. And this is the first problem which you are trying.